This is my textbook's explanation of Euler's method, a first-order numerical procedure for solving ordinary differential equations, also called ODEs. In this video, we're going to discuss the intuition behind Euler's method, visualize the approach, then briefly look into higher-order methods. To understand Euler's method, we first need to understand what a derivative is. For the purposes of this video, it's a function that maps the tangent slopes, some tiny dy over dx, of a parent function. Now, a function that has a derivative can really be viewed as a sequence of lines with varying slopes. From this vantage point, Euler's method, which essentially seeks to approximate the red curve from the blue, makes a lot of sense. Given a certain point on our curve, for this example we'll say 1, 0, we find the slope at that point and use it to approximate the next point. Repeat the process for however many points you want, and we've successfully implemented Euler's method. The issue here is that the solution curve generated is only an approximation. As highlighted by the actual parent function in yellow, the inaccuracies start to significantly build on themselves. For this reason, Euler's method isn't always preferable. Instead, second, third, and even fourth order approximations may be necessary. These collectively are called the Runge-Kutta methods, and I'll share a link in the description where you can learn more about them. To give you a taste, I'll show you an implementation of Huen's method, a relatively simple yet effective second order approximation. It works by using Euler's method to approximate a second y value, calculate the would-be slope at that point, take the average of those two slopes, then yield a final slope shown in red. Fast forwarding through all the other points, we find that the end result is much more accurate. Now, if you want to play around with this, I made a small Repl script which you can find in the description. Just manually input an ODE, copy and paste the output onto Desmos, and see how tinkering around can improve the accuracy.